What's going on, everybody? It's Erik from Panola, and we are still working our way through the objectives of Security Plus. And in this one, we're going to be covering Objective 2.5, given a scenario, implement cybersecurity resilience. And this will be coming from Chapter 9 of our SY0-601 CompTIA Security Plus study guide, which I have the ISBNs to the side here on the screen. One of the ways that we build that cyber resiliency is through redundancy, and that is being really redundant about some of the things that we are cyber resilient in. The idea is that if we have backup systems that are ready to go at a moment's notice or need a little bit of prep time, that we can build resiliency through those backups. Because if our primary systems go down, we have a way to bring the data back to where it was in that original state. Or let's say we have an individual system go down. We have another system that can take its place, or we can push everything over to another system. So however that redundancy works out, which we'll go over here in a little bit, is preferenced by the organization and their policy of backup. We also need to consider separation of sites and servers, especially in those cloud environments. And what I mean is that if we're in a cloud environment, we have multiple sites. That could be geographic dispersed, meaning we have one site in Texas and another site not in Texas. That's really far away as far as I'm concerned. And this means that we need to consider if those different sites are up and operational and maintained and monitored appropriately, just like our primary site is. We have separation of servers. We could be in a single building, but we want to make sure that our servers are separated because different things like power grid, backup power, grounding, there's so many different things. So like I would not put all of my servers in one room. I might have two different server rooms where I have on two different power services for that application. That way, if one goes out, the other one's ready to go or being used simultaneously. Multiple network paths is also another thing to consider, because if we only have one in and one out, let's say we have a small business that only has an ISP provider for internet. Well, if that one service provider goes out, how are we going to get our traffic out to the internet and provide services for our clients? That's something to consider. Maybe we need to have two different organizations be our ISP. ISP number one, which is our primary path, and ISP number two, which is our backup. And we can have it to where our network has more than one way of communicating to the outside world and providing that service, which goes into load balancing like we were talking about with the server rooms. If we get a lot of traffic to our website, and we're not necessarily talking about Google here, but the same idea applies, and we're definitely not talking about geo-dislocation. We're just saying that if our main website gets a whole lot of traffic, how can we spread the love to different servers? We could have 5 web servers that web balance between them. So one fully qualified domain name, such as Erik.com, goes to 5 different servers that are all synced together and sharing the data. So that way, if one user's coming in and occupies server 1 and is using a whole lot of bandwidth on that and processing power, user 2 can come in and be assigned to server 2 for that proper load balancing, and everything on the website still looks the same for all the users. And that's generally how balancing works. Now, we go even further where we do NIC teaming, and that is we have all these users coming in, and if our server only has one NIC, we're limited by the bandwidth cap of that NIC. And you'd have to go and take a look at the physical requirements and capabilities of that network interface card on that physical system. For instance, when I was coming up in the internet, we still had 10 base T. That was like the thing for your T1 connections. Well, that's 10 megabits per second, and if you're overloading past 10 megabits per second, everything's going to bog down because of the bottleneck. You're only pushing through as big as that straw is. But if you have nowadays those 1 gig or 1000 base T system NICs on your servers, let's say you have 4 of them on there and you team them together. Well, now your server has the capability of pushing 4 gigabits per second, because you've teamed all those NICs together and they're working as one. So really it would be one logical IP address for those 4 NICs put together, and that one logical IP address would be pointed to whatever is needed to be pointed to. It could be associated with a DNS name, could host name, or it could be associated with something on the network. So we just know that if NIC 1 is filled up, we can go to NIC 2 for the rest of the traffic. Now, physically, these servers do have to stay on, and we need to make sure that we have power backups. Now, this can be achieved through an UPS, which is a universal, it's a battery backup. But the UPS is in case the power goes out, then we have that battery backup there to make sure the server stays on. But that's only as limited as the charge of the battery will go. So we have generators as well too. So in a perfect world scenario, we would have a server that has an UPS attached to it for that battery backup. And if the power goes out, the UPS will take over instantaneously and the server will continue to stay on. Whereas in the background, we're swapping from shore power, which is commercial power, and going over to generator power. So when the generator comes on, the UPS shuts down and starts recharging, and the server is none the wiser. And that's just how we make sure that the server stays on through power redundancy. See, we may have the generator on more than we want, and depending on where you're at, if the power is always bad, like where I'm from originally, that's something to consider. And then we have storage redundancy. Now, storage redundancy is like, let's say we're doing backups like we should be doing, where we're just doing daily backups or however that may be. We have to have some place to put those backups. And there are different types of media that we use to be able to store those backups. We have stuff like tape. Now, I know that's starting to get kind of in a museum, but there are still systems out there that use tape backup. We have disk like hard drives, whether they be spinning or solid state. We have optical media such as CDs or DVDs, and flash media like USB thumbsticks. Now, with everything going on as technology advances, we now have cloud backups. And we could easily take our system here and say, I want to do a cloud backup to the Google Drive. And that's an option now. But we also need to make sure that that technology is the first. So if our entire organization uses only Windows 11 and, no servers, no nothing, everybody only uses Windows 11, that opens us up to the possibility of an attack. If one system is popped due to a exploit, well, if everybody's using Windows 11 and we're on the same thing, then that exploit can be used on those other systems as well. So we need to consider that we have technology diversity in that maybe we use our workstations for Windows 11, maybe our servers are being used on Server 22 or Red Hat Linux or something along those lines. So that way it's a little bit more difficult for somebody that's a threat to come in and find that singular vulnerability and exploit it on every single system. Now, a while ago, we were talking about backup media and being able to store a lot of data through backup. And on our servers today, we are able to take multiple hard drives and turn them into one, very similar to NIC teaming. But in this case, we're calling it a RAID. And if you're a gamer, it's not like that. It's a RAID of drives, where we store everything on multiple hard drives, and it looks like one hard drive to the system. Well, there are multiple RAIDs. Now, our basic is RAID 0, where the data is spread all across the drives in the array. So let's say you have 5 hard drives and you RAID 0 them. You have one hard drive, logically, made out of 5 physical hard drives, but there's no fault tolerance and all the data is lost if a drive goes out. So if one of those 5 drives eats the dust, then you've lost everything. Then we have RAID 1, which is mirroring. All the data is copied exactly to another drive or a set of drives. So let's say you have 2 drives in that RAID 1 setup. They're both going to show logically the drive space in drive 1, because everything that's put on drive 1 is mirrored over to drive number 2. And so if drive 1 goes out, drive 2 will take over and continue the actual RAID itself. Now, this uses twice the storage for the same amount of data, but you have a perfect backup live of what's going on. RAID 5 is striping with parity, and the data is striped across the drives with one drive used for parity checks. So let's say you have 5 drives. The data is going to be spread across 4 drives, drives 1 through 4, and drive 5 may be the one to say, okay, guys, we need to make sure that everybody's in line here, make sure that the data is spread across equally. Now, you may have a file that you save on this logical drive set that is pieced on drives 1 through 4. So part of the file is on drive 1, drive 2, drive 3, drive 4, and drive 5, where the parity checking is going to happen at, is going to make sure that that file is intact all the way through from 1 through 4. Now, the downfall to this is that only one drive can eat it and still continue. So if, let's say, drive 3 goes out in this setup, the rest of the RAID will continue to work, and the rest of the drives will be able to piece that file or information together. But if more than one of those goes out, let's say 2 of them go out, then you have to be able to do data recovery at that point, because the RAID is not going to work. The good thing is, though, is that in RAID 5, you can replace that drive that went bad with another one in what's known as hot swappable. We have RAID 6, which is striping with double parity. It's like RAID 5, but additional parity is stored on another drive. So in our 5-drive setup, we would have 3 drives for all the information and 2 drives for the actual checksum or parity of the actual data itself. So it's just double checking to make sure that all the data is going across as it should be. Now, it has a slower write performance than RAID 5, since we have to do double parity checking and everything like that. But we can rebuild the arrays after a drive is lost. And if a drive is lost, it will cause a slower performance because it is doing a double backup of checksums. Then we have the master of all RAIDs, which is RAID 10 with mirroring and striping. And data is striped across 2 or more drives and then mirrored to the same number of drives. So in this case, this would be a 5-drive setup, which is our RAID 5, with mirroring across, or putting the data across those 4 logical drives and using drive 5 as the checksum. But we would have 5 more drives doing the exact same thing. So if the first 5 ate the dust, then the second 5 would take over and do the exact same thing. So it combines the advantages and disadvantages of RAID 0 and 1, and then they flipped the numbers and made it RAID 10. So that's all well and good, but what about our virtual machines? Well, regardless of what kind of RAID that we have set up, if we have virtual machines running, whether they be type 1 or type 2 in the hypervisor world, we can take snapshots of those virtual machines that are running. And we do cover this in some of the videos here on the channel as well, working inside a VirtualBox. And a snapshot is basically taking a picture of the system as it's currently running right now, and then saying in the future, let's say we booger something up, we could revert back to that snapshot to where that system was currently taken a picture of. And we would just back up to that point. So if you took a snapshot now, installed another program, and then said, I don't like it, and reverted to that previous snapshot, it would go back to before that program was installed. Now, all that aside, let's get more into the physical aspect of what's actually going on here. And that is, how do we make sure that we have quick deployments for our systems and our sites? Well, the easy one first is that we use imaging for those systems that we're putting into place. We have a new workstation that's coming to the system, and we want to be able to drop it for a new user on the tip of a hat. Well, we use imaging for that, where we have a deployment server or physical media that says we're going to image that server as a baseline. And then everything we add to that would be kind of additional. But if, let's say, the system boogers up, we can just wipe it and put the image back on it. So think of it as like a snapshot for physical systems themselves. And speaking of physical systems, we have the 3 sites that are covered inside of this chapter let me scroll back up, chapter 9. And we have different storage and backup requirements, but what about the actual sites themselves? So if we're working inside of our organization at site A, and for whatever reason, site A gets shut down, we need to move over to site B. Well, there's 3 different ways that site B could be utilized. Now, a hot site is the duplicate of our primary site, and everything is running and ready to go for a swap over at a moment's notice. So I've gone in or site A for our organization, said, everybody pick up your stuff, like your papers and stuff like that. Get out, go to site B. Everything's already running, ready to go. Should be no noticeable difference. A warm site is a duplicate site that generally has everything back up, but needs a little warning so everything can be turned on. So like all the systems are there that we're used to, everything that we've been using, but I need a little bit of heads up because I got to start turning everything on. It's ready to go though, can be up within like an hour or so. And a cold site is a site that has some of the systems, some of the duplicates that we have that are needed, but isn't really ready to go unless we put some work into it. So yes, we do have a backup site that we can go to, but it's definitely not at a moment's notice. This is more like I need a couple of days to get everything up and running so we can duplicate what we're doing. It just takes a little bit of time to get everything up to that point, and that's why it's a cold site. Now, the reasons that we may swap from hot, warm, and cold could be like utility bills. Having a duplicate site like a hot site requires us to keep paying the same cost that we do for primary site A. So now it's site A times 2. Whereas if it's a cold site or somewhere in between, we could reduce the cost of those utilities, keeping everything up and running. So site A has its standard practice of, utilities every month, and site B is like half of that. At the end of the day, do not forget to implement the same security practices that we've been studying and going along together with up to this point on what we've just been talking about for security precautions. See, everything that we do is under the aspect of security. We may not be technically implementing some of the things like that hot, warm, and cold site or the raids themselves, but we just need to make sure that the security protocols are put into place to make sure that they are up to snuff. And that comes down to stuff like CIA Triad, authentication and authorization, and making sure that overall all the patching has been done on these different sites and everything is secure or to its best ability of security. Now, definitely check out our stuff on panola.edu. We have courses like this that go way more in depth and help you work towards that associate's degree in cybersecurity. We also cover networking and digital forensics. Our classes are online. If you've liked everything that we've been doing so far, go ahead and like and subscribe. Let me know how I'm doing. I hope you all have been enjoying this, and I will see you in the next.